Okay, what we've been doing up to this point is putting numbers into scientific notation. What I want to do now is pull them back out of scientific notation to a regular number. When we put numbers into scientific notation, like this 6,201, if a decimal moved to the left, then we would get a positive exponent. And if a decimal moved to the right, we would get a negative exponent. And that was putting regular numbers into scientific notation. But when we pull them back out of scientific notation into a regular number, we do the exact opposite. So if we had 6.21 times 10 to the third, we have a positive exponent, but we would move the exponent to the right instead of the left. So we would have to move it 3 times to the right. And also if we had a negative exponent, we would move it to the left to get it to a regular number. So it goes to the left like this, and this goes to the right. So that's the major difference. We're doing the same thing. Everything else is the same. So what I like to do is just drop the number down and write the numbers down without putting a decimal anywhere. So I'll look at the exponent and I'll know what direction to go. So it's positive, and to bring it out of the scientific notations to a number, we would move the decimal to the right. So 1, 2, 3. And what that's doing is multiplying this number in increments of 10 3 times. So we would take this number and multiply it by 10 once, and the decimal would be moved here. We'd multiply by 10 another time, the decimal would be moved here. We multiply by 10 another time, it would be moved here. We're just doing it in a compact way. So we can just drop the number down. And the exponent is 5. So what I like to do is make sure I have at least 5 positions the decimal could be moved. So again, we have a positive exponent, so we would move the decimal to the right. The exponent's 10, so we would move it to the right 10 positions. 1, 2, 3, 4, 5, 6. I should have dropped the number down. So 1, 2, 3. So our decimal ends up right here. So we have a positive exponent, and we're moving from scientific notation to a regular number. positive exponent, the decimal would move to the right. It would be positive, and the function would be multiplication. So it's multiplying this decimal number in increments of 10 two times. If we multiply it by 10 one time, it moves the decimal here. If we multiply it by 10 an additional time, it moves the number here. So we would have 742. So with negative exponents, you can drop the number down. And I try and have at least the same amount of numbers or more. 3 here, I'll put another one here. Well, actually, I'll put quite a few. So the exponent's negative. So the decimal will move to the left 4 positions. 1, 2, 3, 4. So we have 0.000624. And the function is division. So what we're doing is dividing this decimal portion in increments of 10 4 times. So we divide it by 10 one time, we bring the decimal here, we divide it by 10 another time, brings the decimal there, divide it by 10 another time, brings the decimal here, divide it by 10 another time, and it brings the decimal there, and we end up with 0.000624. So we can drop the number down. So the function is division because we have a negative exponent, and the decimal would move to the left, or L. And it would move 5 positions. So 1, 2, 3, 4, 5. And what we're doing is dividing this decimal number in increments of 10 5 times. So we would have 7.211 divided by 10 one time would bring the decimal here. We divided the decimal by 10 more times, we bring the decimal here. We divided an additional 10 increments, it would be right there, and so on. So the final number would be 0.000007 211.